So we are going to start our session today. Today morning we are going to have 3 important talks, especially that is from the trust, how we create trust on the internet. So all these 3 talks are aligned with that theme. So first, I would like to invite Mr. Shigeyuki Azuchi, Director and CTO of Chaintope. So his talk title is Characteristics and Protocol Design for Enterprise Blockchain. And he's the CTO of Chaintope, and Chaintope is one of the most promising startup in Japan who is working great works in the blockchain industry. So, Mr. Shigeyuki Azuchi, please, floor is yours. Welcome.
Hi, good morning. So today I talk about the characteristics and protocol design for enterprise blockchain. So I'm Shigeyuki Azuchi, CTO at Chaintope Inc. So Chaintope is a blockchain integrator, developer and deploying enterprise blockchain Papyrus. So we focus the 4 domains. The one is traceability. This certification of origin and distribution records for foods and agricultural products and plastic and industrial waste and digital passport compliant with the EU regulation. And then sustainability, this visualizing and evaluating CO2 reductions. And then trust service, issuing local government documents as digital certificate, and issuing paper-based certificates, including those from financial institutions as digital certificate, and enable third-party verification of digital certificate authenticity. And last is digital assets, issuance and management of regional currency and digital premium badges. So today I talk about the characteristics blockchain, including some concrete example of blockchain design to achieve these. Okay, blockchain technology began with the invention of Bitcoin by Satoshi Nakamoto. What makes Bitcoin different from traditional system? So in traditional system, identity and number of participants are known and has trust. At least majority of members will act as a correctly. But in Bitcoin, so consensus built in a distributed environment where the number of participants is unknown. This is achieved by Nakamoto consensus, which includes proof of work, and confirmation of transactions between participants who do not trust each other. This is achieved by the digital signature scheme like ECDSC, and prevention of double spend without a central authority. From a model of trust in the central authority and third parties to a model of trust in protocol and mathematics. To trustless trust. Such paradigm shift is also required in the business domain. So rather than blindly trusting the company to behave correctly, you can verify that it is doing the right thing. This characteristic blockchain can be used as a tool to achieve this. However, we cannot simply replacing existing system with blockchain. So there are several issues when using the blockchain, which operate in distributed environments and has a shared ledger for business use. I will take three typical issues and explain how we are trying to solve them with concrete example. So first issue is governance. In decentralized public chain without a central authority, trust is placed in the protocol rather than a specific organization or individuals. But without administrator, so reaching consensus on protocol change, such as adding a new feature, it's become difficult. So this decision making is difficult to on the blockchain that has no administrator, such Bitcoin, and adding and changing feature is very slow. So second issue is scalability. Transaction throughput in public blockchain is limited compared to the centralized system. In Bitcoin, it's around 10 transactions per second. In centralized system, it's around several thousand TBS. So improving transaction throughput is essential to support many users or small machine-to-machine payment. But simply increase processing capacity lead to centralization. The third is privacy. Oh, sorry. Okay. Third challenge is privacy for file personal information in stored directly on blockchain. So if address and account linked to real-world identities, it becomes possible to track your behavior. So, yeah, and currency fungibility must be guaranteed to ensure that currency you hold is always usable. If you don't take measure to protect your privacy in advance, you cannot strengthen its relation. Okay, let us first consider the governance issues. Okay, first look, let's look at the certification, classification of blockchain. So first is a completely public blockchain such as Bitcoin and Ethereum. This blockchain can reach consensus even if the number of participants is unknown. And second type is permitted blockchain, so called private chain or consortium chain. So in this type, so agree on predetermined number of nodes and client access via API after authentications. There's a limited to number of participants to reach a realistic consensus. The third is a hybrid model of these two types. So Tapirus, which we developing, is this model. So Tapirus consists of permitted governance layer and a ledger layer that anyone can join. Let's look more specific. Permitted governance layer introduce a signer network that generate blocks through multiple signature from multiple signers. This means that only predetermined member can participate. Each signer collects transactions and broadcast to the ledger network. and assemble them into the block. And create a digital signature for the block and broadcast to completed block to the ledger network. This layer supports faster and more stable block generation. On the other hand, so ledger layer is permissionless model in which anyone can join, anyone can create and see and verify transactions. Each node in the signer network use the T of N threshold signature scheme for signings. This threshold signature scheme requires that T participants to cooperate to create valid digital signature for the aggregate public key. That is aggregate of the public key of all N signers. If existing signer agree, new signer node can be added and changed or deleted. Such update agreements are recorded on chain, and the consensus rule of chain can be changed. In Tapir's ledger node are fork of Bitcoin Core and customized. We chose to base Bitcoin Core our network because it has been running in decentralized environment for 16 years and has predictable resource demands and the chain growth. Okay, let us second issue. This is a scalability issue. The simple way to improve the scalability is on-chain scaling. This means increase the block size. Bitcoin creates one block every 10 minutes and has maximum block size is 1 megabyte. This block can store 3,000 to 4,000 transactions. It's about 10 TPS. As more people are using the Bitcoin and block become full and more transactions cannot put into blocks, the overflow transaction waits for the next block. This causes confirmation time is to increase as transaction volume increase. In 2017, there was growing interest in solving this problem by increasing the block size. However, Bitcoin developer opposed this, and so Bitcoin Cash chain to create the block size, to increase the block size. Its initial size was 8 megabyte, and then it's expanded to 32 megabyte. And even more ambitious, Bitcoin SB was forked from Bitcoin Cash. Such a block size is 4 gigabyte. However, on-chain scaling has problem. This includes the resource requirements for the node, increase the transaction verification cost and network bandwidth to receive and send a big block, and increase disk space. In case of 4 gigabytes, the data continue to grow at 200 terabytes per year. As a result, so network became centralized. The number of nodes operate decreased due to resource cost issues, so network becomes centralized. About security, security is guaranteed by verifying all transactions. Fewer verifiable user means more outsourcing of transaction verification, which reduces the security. User cannot verify the correctness themselves. Ultimately, the number of chain operators will be limited, so making it permit blockchain. and the benefit of blockchain will not be realized. So increasing the block size also faces synchronization issues. So the new node that has just joined the network download 4 blocks from connected peer and build a local copy of blockchain. When all block has been copied, blockchain is synchronized. So if you make a 4 GB block, you cannot simply sync them anymore. So you need to adopt an on-chain scaling strategy. Off-chain scaling would be a good option for the scaling blockchain. So Bitcoin has introduced an off-chain based solution called Lightning Network to increase the transaction throughput. This is called off-chain scaling or layer 2 scaling. Since its development in 2018, it's perhaps most widely used off-chain technology today. The solution allows funds that deposit in Bitcoin on-chain transaction to be used as a channel to make payments through similarly deployed channels without recording the additional transaction on-chain. Even so, transactions are not recorded on-chain, funds exchanged off-chain cannot be stored. The difference in characteristic between the these two approaches is also interesting. Bitcoin is confirmation every 10 minutes, 10 TPS and high fee. But Lightning, this is instant payment, million TPS or more, and low fee. This difference in layer creates this characteristic difference. Yeah, next is scaling effort we are undertaking. We provide a traceability in supply chain using a blockchain for issuing digital passports. How can we this kind of how can we do this is this kind of recording on the blockchain. The naive approach is assign unique identifier for to each product, then record where the identifier has traveled using a blockchain transaction. A Bitcoin transaction has inputs and outputs and sends the input coin to output destination. So in tabular transaction, which have same structure, so movement can be expressed by having the input represents the from, and the output represents the to. This means the transaction graph on blockchain become a trace graph. But if product ID is registered directly on blockchain, as in the case of using a database, at least number of unique product ID multiplied by the number of products that will be recorded on the blockchain. This means that the data space grows linearly with the number of items to be tracked. For example, trying to track the supply chain, such as recording the movement of every single sandwich. So that would require a huge blockchain, which would lead to the centralization. But using the cryptography, we can reduce the burden on the blockchain layer. So we use the accumulator that use the RSA trick. By introducing RSA accumulator, so the product information recorded on blockchain can be compressed to the fixed size. First, initialize RSA accumulator. This only need to be done once at the beginning. So choose the large prime number P and Q uniformly at random and calculate N P multiply Q. From an RS group, modulus N, select N, and then select generator element G from the RS group. Then initialize the accumulator A0 is equal G. When you're adding the item, calculate the hash value HX for product ID X, where H is a hash function, just output prime number. Then compute the power remainder of the value for the current accumulator value. Compute this expression. And A1 is updated accumulator value. Since the modulus is n, so the accumulator value is within the fixed size. So repeat this for number of items to be moved. When you proving the element membership, the inclusion proof that element is X is included in A1 is A0. So if prover can provide A0 and X for A1, this is current accumulation value. The verifier can verify this expression. So this compressed accumulator value is then included in blockchain transaction. When we record the movement to item A, B, C, we calculate accumulator value by adding them together. Instead of storing the product ID directory, so store an accumulator value that contains the product IDs. The advantage of using RSA accumulator, the order in which elements are added or removed does not affect the result. The generated accumulator value is always fixed size, like the 2048 bits, very small. Inclusion and non-inclusion proof of elements can be generated. So by combining on-chain accumulator value with off-chain inclusion proof, tracking can be achieved with the minimum on-chain footprint. So the key for efficient scaling, minimize the on-chain footprint. First, on-chain throughput presents other issues. And do not record large data directly on-chain. By recording on the commitment, just can fix the order of transaction. You can design a custom protocol. Okay, let us last consider the privacy issues. So supply chain traceability sometimes requires confidentiality. So for example, the traceability of battery recycling with materials. Here's 3 transactions. In tracking transaction A, use battery X and Y and extract material set A. The materials to be recycled include cobalt, mangan, and nickel. In tracking transaction B, use battery P and extract material set B. In tracking transaction C, use 2 material sets A and B, then create the recycled battery C. We can represent battery recycling using the transaction graph, but manufacturer wants to track the materials of their products as per of recycle. But they want to keep the composition of the materials secret. This is a trade secret. This problem can also be addressed with the cryptography. Similarly, in cryptocurrency world, we want to keep information about the amount of money transferred confidential. So a mechanism called confidential transaction was developed. It is actually used by the cryptocurrency such as Monero, which enhance the privacy. In Bitcoin, the public key like a P called XG information and the amount recorded directly in output of the destination. The trade amount is visible to everyone. So in confidential transaction, the transaction amount is hidden by encoding it as a Pedersen commitment. Commitment is RG plus VH. R is a blind factor. G is generator point of elliptic curve. H is nums point. Nums point means no one knows logarithmics against the G. Since the commitment has homomorphic properties, so it is possible add and subtract amount while keeping them secret. For example, let's create a transaction with two commitments A and B. So input as input and commitment C is output. Then calculate A plus B minus C. In the sum of input amounts is equal to the sum of outputs. The coefficient of the nums point H will be 0 and will disappear. So in this case, digital signature can be generated using R1 plus R2 minus R3 as a private key. The balance of amounts can be verified, not cheating. Let's extend this scheme. So we want to keep secret the amount of each materials in the product to hide the value of each materials. So define corresponding nums point for each. This can be prepared using the hash2curve hash function defined in RFC 9380. Then using these points, encode the product material information as a vector Pedersen commitment, like this. Now we encode each product with vector Pedersen commitment and apply it to the transaction as before. The transaction in which recycled battery C is made from material sets A and B. Mentioned area looks like this. So the commitments has homomorphic properties. So calculate A plus B minus C, nums point will disappears. So proving the digital signature for public key proof. There are no cheating. So and transaction made possible with while keeping the amount of material secret. So if we wish to prove the contents of each product for material set, we disclose the content. Proba provide blind public key and amounts of all materials and digital signature for blind public key. Verifier checks calculate the commitment using the blind public key and the match of all materials, and verify that it matches commitment in transaction, and then verify that digital signature is valid for the public key. Okay. Furthermore, by changing the commitment scheme, it is possible to disclose the only parts of materials, like only mangan. One possible approach is recently published pairing-based polynomial commitment scheme, like KZG. So for lack of time, skip this scheme. Okay, and then so I introduced how to utilize blockchain mechanism using several examples. By stacking the higher layer on top of the first layer, the blockchain, various extensions become possible. So, and what's interesting is that the characteristics applied to each layer change lightning, like the Lightning Network. This is similar to how the TLS layer is layered on top of the TCP/IP and application layered on the top of that. Okay, now let's move to the summary. So for enterprise to be able to handle change that affects the business domain decision is currently difficult with a completely open chain like the Bitcoin, and requires governance layer, and currency volatility is also issues. Operation costs cannot be calculated. So blockchain provides transparency of the data that can be verified by anyone. So there are other challenges, issues with traditional system, such as scaling and privacy. However, these issues are currently being researched around over the world, and the application of various cryptographic technique is being considered to address these issues while maintaining the characteristic of being verifiable without centralization. So solutions to these issues are being researched all over the world and very hot. Such efforts continue to result in the new inventions, especially those related to the multi-party computation and zero-knowledge proof system. So it's an interesting field. So if you are interested, please give it a try. Okay, that's all.
Thank you, Mr. Azuchi, for your great, insightful presentation. And from your presentation, we understand that you are addressing very deeply from developing a protocol to the business layer, addressing the business application layer. Okay, so I think many of you have questions. So please, floor is open for the question. So please raise your hand. Okay, you go first. So today I want to see more hands to be raised, not the old faces that you raised yesterday. Yeah, please.
Okay, thank you for interest topic about blockchain, and I would like I have interest with like Taproot's API of your product, your company. And then also my question is about the NFT. How to build the trust for transfer and license of copyright to NFT for podcaster? Thank you.
Can you please repeat your question?
Oh, okay. My question is how to build the trust from your customer of NFT, which like for transfer and license of copyright, something.
The trust of copyright is defined by outside the blockchain. So, in Taproot, suppose the Oracle scheme that's enabling external information in Taproot blockchain, and then they trust that your third-party Oracle, the copyright can be verified via Oracle scheme.
Okay. Okay. Thank you. Thank you.
Okay. Any other question? Okay. You answered. Okay. Go ahead. Okay. So, what?
Thank you. So, what is the? Oh, okay. So I understood that the blockchain system is very huge and complex, and we have to study a lot to even begin with working on blockchain. We may have to know so many things. But now, like if, because I want to encourage people to start working on a blockchain. So in that case, what is your recommendation? From which point we can start to study blockchain? Like, do you have any recommendation? What is the first step that we can get familiar with blockchain?
Yes. First recommendation is the Bitcoin white paper. It's very short size and very interesting insights. So and then so second step is so depends on your specific. Yeah.
Okay, so read the blockchain paper. Read Satoshi Nakamoto's Bitcoin paper.
Yeah.
Yes, okay. Thank you so much. Great answer.
Next.
Thank you very much for your presentation. Very technical and a lot of interesting points. Well, I study economy, basically, and one of my major points of interest is how to implement or how countries are implementing blockchain technologies into their economic system. For example, El Salvador, which is one of the countries that is trying to do that, and smaller countries are changing into cryptocurrencies, right? So my question is, what do you think is the major challenge for institutions to implement different kind of blockchain systems? Thank you for the translation.
Yeah. Sorry, my English not well. The first is understand the blockchain-based blockchain scheme like the Bitcoin and the Ethereum. Yeah, and then first the company is interest the it depends interest the interest layer for your company and other communities. It's not a clear answer. Sorry.
Thank you very much.
Okay, next, please.
Thank you so much for the thank you so much for your presentation, sir. So my question is, like, I understand that Chaintope is a first penguin in the business, and aside that, like, it's currently very volatile, so the Bitcoin industry overall, and that's why cost calculation and Eikyo Kaihatsu is very difficult, business development. So since you cannot kind of ensure, like, see a future for the cost calculation, how are you doing business development? Like, how do you create bigger plans to expand your product to the greater scale?
Business development is very hard for our company also. But like the traceability, so EU applied the new regulations. So just this regulation is a chance for us to deploy our blockchain system. But just these layers guarantee the transparent verification and any more like the more value about the shift reduction, and everyone can join our network and trade each other I want to expand our business more quickly. Yeah.
I hope more people join your network. Thank you, sir.
Thank you.
Hi, good morning. This is Rakiba Sultana. So I have one question. Blockchain started like from 2008, right? Satoshi Nakamoto that time started, but still people are, many industry people are not ready to use it in their businesses. So what type of challenges did you face from business perspective to, impress or to convince, in like more perfect sense, to convince your clients or convince people to use this, to use blockchain in their businesses?
I think he already answered this question from the same challenge.
Okay.
And this too is the same question. So it's challenging. There are many challenges to solve. He already answered that.
Oh, okay. Okay. My other question is in Tapirus, for like protocol-wise, you used BFT only, like in Tapirus. What blockchain protocols did you use? Can you please repeat again?
Tapirus itself is a protocol.
Oh, sorry.
Yeah, so Tapirus using the Bitcoin as very similar to Bitcoin, but the exclusion is the consensus algorithm.
Consensus algorithm. Okay.
In Bitcoin, using a proof of work, we are using a proof of authority, so using the digital signature scheme.
Digital signature.
Yeah.
Oh, okay. Okay. Yeah. Thank you.
Okay. The last short question.
Okay. Hello, Professor. Thank you for such an informative presentation. I would like to inquire that there are many students who are beginners. So what you will recommend to start the blockchain with you and with other members? So that's the big challenge. And you know that NFT is the need of the market nowadays. So what is your recommendations for the beginners? Thank you.
So I think the same question here also asked. Start with the Nakamoto's paper, and also Tapirus is open source, right?
Yeah.
And they have also many application open source, so you can try.
I think her question. So I think you're somewhat specific to the NFT,
And
right?
NFT, yeah.
Yes. Tapirus is our business domain blockchain, but it's an open source. If you want to use it, you can launch the Tapirus and custom Tapirus network. Anyone can set up this network, and you can set up this network. You can use it. But little difficult, yeah.
Yeah, it's really difficult. Thank you for clearing me. Thank you very much.
Thank you.
That is the last. So maybe he is here today, so you can ask other questions. And our next two more presentation is related to blockchain. So once again, great thank you to Mr. Azuchi for his great speech. And I think it's open source and it is addressing business layer, including the business layer from protocol to business layer. So many of you can join the community. So hope it's going to change the landscape of the blockchain industry. Thank you.
Thank you.